Hello, this is Dr. Strickland. In this video, we will finish up our investigation of the reactions of aldehydes and ketones with nitrogen nucleophiles. Take a minute to read through these student learning objectives. These are the things you should be able to do by the end of this video so that you're ready for the things we will do together in class. Now, last time we talked about reactions of aldehydes and ketones with primary amines. And in that case, you form what's called an imine. When you do a reaction between aldehydes and ketones and a secondary amine, you form a compound called an enamine. And the "ene" part of this name is from the carbon-carbon double bond, and the amine part of this name is from the sp3 hybridized nitrogen. Now you can put little squiggles here because these are not supposed to be methyl groups. It's just attached to the rest of the molecule. And so that's what I do when I don't want to draw out an entire molecule. I just want to focus on what's happening at the functional group. So the first thing that I would like you to do is to take this general reaction pattern and apply it to this specific situation and draw me the product. So pause the video, draw the structure, and come on back. Okay, welcome back. Now I wanted to show you how I would do this. You know that the nitrogen has to be attached to what used to be the carbonyl carbon. And the double bond involves that same carbon and its alpha carbon. In this case, it wouldn't make any difference if you chose this one or that one. But there's a reason why you don't form the carbon-nitrogen double bond in the final product of these kinds of reactions. So we're going to walk through the mechanism, and you're going to see that it looks exactly like the mechanism involving a primary amine until you get to the very end. And when you get to the end, you'll see why it has to be different. All right, so eventually we're going to need this alpha carbon, so we're just going to carry it with us through this mechanism. So secondary amine, of course, means that you've got two alkyl things attached to the nitrogen. They can be the same or they can be different. And then a hydrogen. And of course, there's a pair of non-bonding electrons, which is how the nitrogen can be a nucleophile. And so just like with the reaction of an aldehyde or ketone with the primary amine, with the secondary amine, it starts the same way. Now, as we're going along, it would be a great idea for you to draw the intermediate ahead of me. So if you want to pause the video and draw the product of the step, I think that would be a great idea for you to do, because I think it will help you to remember the steps better. All right. So very much like what you saw with the reaction involving a primary amine, the nucleophilic attack is followed by a protonation, a deprotonation, and then a protonation at the very same kind of spots. So we're going to use our proton donor, whatever it is. And it's fine for you to use this as a general structure of a proton donor, but it turns into the proton acceptor. It becomes the conjugate base of whatever it was. And that's what we will use in the deprotonation step that follows. Positive charge up there. All right, protonation, deprotonation. Where do we get our deprotonation? Oh, we got to do something about this positive charge on the nitrogen. Right, so now we've gotten to a point where all atoms have a formal charge of 0. But it turns out that the molecule has something else in mind. So we're going to do a protonation of the hydroxyl group, which will get the water ready to be a leaving group. The hydroxyl group accepts a proton from whatever this proton donor is and turns into an OH2 plus group. So I'm just going to come back over here to the left this time. All right, there's the oxygen that has 3 bonds. A couple of squiggles there. So we're going to have an elimination just like in the mechanism involving the formation of an imine and the loss of water. And we've formed this guy. But the problem is we've got a positive charge here on the nitrogen, but there isn't a hydrogen that can be removed in a deprotonation step. Instead, the deprotonation happens somewhere else. Where does it happen? Well, it has to happen here. These electrons go back onto the nitrogen and satisfy the positive charge. And I'm going to draw that like that. And this like this. All right, so the mechanism is exactly the same. Same number of steps, same kinds of steps, same order, until you get to that last deprotonation. All right, so enamine hydrolysis is very similar to imine hydrolysis. Basically, it takes you just back the way you came, except that the products are what would have been the starting ketone or aldehyde and the conjugate acid of that secondary amine. So I'd like you to use this general reaction pattern over here, pause the video, draw the structure, and then come on back. Okay, welcome back. Now you know that the carbon-oxygen double bond has to involve this carbon right here. And the oxygen goes where that nitrogen currently is. So that tells me that the carbonyl part is cyclohexanone. And then this is a cyclic secondary amine. So here's the cyclic part. And then it's got 2 hydrogens attached to it instead of 1, which is how it gets to be the conjugate acid. Now, one more thing here with nitrogens. You can actually take this imine and enamine stuff one step further if you've got a reducing agent in the mix. Now, if you've got an imine that was made using ammonia, you can use just regular old catalytic hydrogenation conditions, hydrogen gas with a palladium on carbon catalyst. And the imine will be reduced to a primary amine. If you made the imine using a primary amine to begin with, it will be reduced to a secondary amine using this fancier hydride transfer reagent called sodium cyanoborohydride. And if you made an enamine using a secondary amine, it can be reduced with the same compound to a tertiary amine. So this is a way of making a larger amine, basically. So let's see what we're going to do here. You know that if you had this guy here, this is a primary amine. So a primary amine with a ketone, is that going to make an imine or an enamine? It's going to make an imine. And then the reduction is with the carbon nitrogen double bond. So there's hydrogen added both to the carbon and to the nitrogen. So there's the hydrogen added there, and then the alkyl group is just the same. So if you said, you know, I'd really like to have this secondary amine, I wonder how I can make it. Well, turns out you can. And it's one pot, one step. But I wanted to show you, you know, this intermediate, which doesn't hang around long because the reducing agent is already in there and reduces the double bond to a single bond. All right, please answer the question at the end of this video and then come on back.